All right, thanks for joining everyone, or for all those of you who watch later. We're going to try and do maybe monthly video update in addition to our regular Tuesday evening Slack meetups, where we'll go through and demo some things, maybe do some how-tos and stuff like that. So in two parts tonight, I'm going to talk a little bit about the crawling technology we're working on. Samir's going to talk about AWS Lambda, what it is, and how we're going to use it for that. So I'm going to go into the OpenHouse Crawler repo. This is something to clone if you're interested in working on some crawls for the project. What we're trying to do, and what the project has really been an evolution of, is finding ways to break down what is pretty much a big project for even each site into smaller subcomponents and provide software and things as a service to make that easier. So obviously the API came first, and that was great. People could push stuff to it, but there's a lot of steps to that. So can we make that easier? And we built the background uploader and some Python code that helps communicate with it from once you have your data in a very tabular fashion that you probably end up in working with pandas or something like that. Now there's the added task of crawling, and crawling has some added difficulties. I'll go through why. And I've got a Jupyter notebook here that's going to demo some of the code that's been written so far that'll hopefully help people contribute to crawling without doing quite as much work as things were in the past. And this is just one step in, I think, making the whole process easier. So here's some reasons why we're going to provide this crawler. First and foremost, everyone should have good netiquette. I know that term's fallen a little bit out of fashion, but basically means whomever you're crawling should not be terribly displeased with that. So if you don't know about robots.txt, it's a file any website can put. I think I have one at Data Skeptic, robots.txt, and it just gives some, so I'm pretty open. I say I allow all agents, and the only thing you shouldn't look at is hiddenpage.html. I bet a site like Google has something more complicated. If you were a good citizen of the internet, you would respect all these things, and that could potentially be a lot of code to write. So we're leveraging a library that helps enforce whether or not a page is crawlable according to robots, and that's just one part of the crawler service. It's also going to do some caching. If you're anything like me, when you develop stuff, you kind of go iteratively. You try something, you see if it worked or not, you make an improvement, and if you're calling a function and rerunning it, fixing things all the time, and you're constantly hitting a website, that would be really bad, so you'd want to have some sort of cache. Additionally, when you crawl, you may find that different pages all link to the same pages, so it's important to not crawl something twice. So we're going to provide a lot of the crawling facilities, also how we can expire that, so you can intelligently decide, oh, I'll recrawl this once per day or once per week or things like that. There's a lot of failures that could go wrong, from the network to some sort of weird intermittent issue on your computer or your Wi-Fi. So how to gracefully handle those and just do general error management is something else we provide the basics for here, and we may improve upon that in the future as well. There's three things you'll have to write. The first is a function, and we'll go into this in more detail, that expands the pages, figures out what to crawl. Another function that gets the content of the page. And then this demo, the crawler, will also prepare all that data to be uploaded to the OpenHouse API. So we're hoping you have the minimal amount of code to write to do this. Here's what you'll need if you wanted to use the crawler. You'll need to have S3 credentials for Amazon AWS S3. That's a file storage system you can look up if you don't know much about it, and we're certainly here around on Slack to help you if anyone has trouble getting signed up. There's also a configuration file. I'm going to call mine openhouse.config, but on the repo, I've pushed template.config. Let's take a look at that. So this is something that doesn't have my passwords in it, but looks very close to what my config file is. So this is my username and password for the OpenHouse API that you can sign up at openhouseproject.co. This is the base URL you want to push to. I might change that to, dev API or my own box, but this is the formal production system we have. Wait time is a general rule of how long you would wait before hitting the same page on the same site more than once. Some values that we'll talk about in another area because these really relate to how the data gets pushed. And lastly, your AWS access key and secret code and whatever you called your bucket. If you need help getting this set up, let us know, but pretty much anyone that knows about S3 and can set up a bucket probably knows what this is. So moving on, you'll need to write three things: the expiration rules that I'll show you in a second, and those two functions I mentioned, and then you run all the code and wait. So I've got some basic imports here. The site I'm going to crawl is the site mypropertyrecords.co. This is a fake site for demonstration purposes, so let's take a quick look at it. mypropertyrecords.co has a couple of states, so let's see what's in these. I don't know if we got a Washington, D.C. here, historic fixer-upper. Okay, so I definitely am interested in getting this. The address is good, the price is good. I don't know like how many bedrooms or bathrooms. So in a lot of cases, there's a more detailed page as there is here. Let's go into the details. Okay, cool. Here's the actual data I'm really after, but it's of course in HTML. This needs to get crawled and processed and whatnot. So I'm going to show you a quick trick that's available in Chrome that I'm really fond of and will help you do the crawls the way I'm going to show you in a second. You go to View, Developer, and JavaScript Console. And there's equivalent tools in Firefox and other places, but this is where, I'm sorry, this is also useful. What I meant to do was right-click and say Inspect. And the reason I right-click, or on the Mac it's Command-click, is because if I point to something like I'm interested in the address, and I Command-click, or Control-click, Inspect, it's going to take me to the exact place and highlight in the source code of the page for where that element exists. So I can see the HTML structure, its classes, things that CSS will use, stuff like that. We're going to use a library called Beautiful Soup, and being able to see it in this way helps us speed up the Beautiful Soup development process. If you're not familiar with that Python library, you should go read up on that elsewhere. There's great demos and on blogs and YouTube and wherever else. You shouldn't have a hard time finding out good training for using Beautiful Soup. So this is one of the records I'll be after. Let's just see what else. In California here, okay, we've got two properties. We've got the charming villa with art included. I guess that should be villa. Historic castle-inspired home. So these two we'd like to pull in as well, both from their detailed page. So you see the site is the sort of root page, then some state pages, and each state page will contain some listings. So we're going to have to crawl through all that, find these detailed pages, and get the data from them. So for the caching, we want to set some expiration rules. The default requirement, what you might want to start with is this. So this would say, by default, and this is a convention of our crawler, you'll just have to kind of memorize or learn that this is how we do it. By default, you want to take the current date and add 1 day, and that's when it will expire. 1 day's time seems pretty reasonable for a lot of crawling situations. There are other reasons you might want to look at not expiring something so quickly. So we provide this starts with facility. We might later on provide some more regex type matching options. Right now it's just starts with, seems to suit most of the needs we've uncovered. If it starts with mypropertyrecords.co, actually, and this should be index.htm, then I'm going to only expire that on January 1st of 2099, in other words, never. And I'm going to do that because when I look at the root page, /index.htm, there's no properties here, and they're probably not going to add any states because there aren't going to be any new United States. Now, of course, maybe this site would expand its business, and in that case, I might expire it more frequently, but for demonstration purposes, wanted to just put that in. So those are our expiration rules. If you just have the default, that's perfectly fine too. So the first thing you want to do is define how you expand the links on that page. In other words, there's a lot of links here, these 5 links and this About Us link. What should our crawling system do with those? How do we know which are the links you want to crawl? Like Washington, D.C., we definitely want to crawl and get this property. About Us, probably don't want to crawl that. Nothing here of interest to OpenHouse. So we'll skip that. So I'm going to run through how I do this in kind of my process for development. You ultimately need to write this function, but let's just do it kind of piece by piece. So I'm going to grab one of those URLs, and I'm going to get it with requests. And I'm just going to double check, does that give me a 200 response? Okay, so we're good. Now I'm going to grab that content out of the request, and I'm going to make a beautiful soup object. And what that'll give me back is a nice formatted version of this. If I go through and explore, I can see that there's, the way the site is structured and the way the DOM is built, so I can take advantage of some of these things. So I definitely am after the links. On this page, where are the links? Let's see, here they are. And I noticed that the links I'm interested in to expand, like these different state views, they all have this menu link. This particular page, here's one of the properties. The link to the details page, let's roll over that and inspect. That has the class of property-links. So I'm actually very fortunate, mostly because I made this contrived example. I can find all the links on the page. Let's just, for the record, let's show why I'm doing it this way. If I just did find all links on the page, that's perfectly fine. but you'll notice I get about us in that package. And I don't like that because I don't need to crawl that page. It's a waste of my time and a waste of that server's resources. So I'm just going to look for those that are menu links and property links. And those are all the links I want to give to crawl after this. Now we just need to wrap up that logic into this function. It's a function, I call it whatever I want. It takes content, which is a string, or a Unicode, I guess, that has all of the raw HTML for the page. And we need to return response, or RESP, which has this format. If it fails for any reason, we should mark that true so that the crawler can decide what to do if it sees a lot of fails coming through. And if it doesn't, we just want to add all our links to this list. So I'll create a beautiful soup object. I'll pull out the listing pages, property pages, and then I'll just extend that and return it, and I'm done. That's all I need to do to pull links out of the page. So let's define that, and let's just do a quick test since we have the content for both. Sure enough, we get content fail false, which is what we want, and we get a list of all those links. So this looks good to go. Now we need to extract the content. Again, I'm going to make another sample here. I'm, in this case, going to get this property. Let's just take a look at what that is, since the URL itself isn't very obvious. It's this, the Getty seems to be for sale here for $10 million. No baths, or no bedrooms, mini baths, 20K square foot. All right, that's definitely a property I want to pull out. So same story here. Actually, let me pull that back up. If we were to inspect the links, we would find, I'll skip this for time, that these have spans around them that also have classes we can take advantage of. Now, you're not always going to find that most sites are structured in the most ideal way, the way I've generated this. Oftentimes, just write more complicated logic, like maybe you grab the div that this is stored in, and then you have to parse the text out or strip out a word. This kind of stuff can be challenging, but you can find great tips for how to do good, beautiful soup parsers on the net. And if you're having trouble, by all means, drop by our Slack channel and ask for advice. These are kind of like fun puzzles to some of us, and we're eager to help you solve it. So beautiful soup, when you do a find, it returns none if there aren't any. So if maybe one page on this whole site was missing the price, I said let's return -1, which is this convention we're using to say, you know, the price is unknown. I go through, and when it's a beautiful soup tag, I pull out the text of it, which will strip away the, you know, the outside the wrapping HTML tags. Or if it's a string already, I just return that. Or actually, if it's anything else already, it could be none, or it could be the string. And then I just do a little bit of magic, stripping out the $sign and the comma from the price, because I want a number, not a formatted number. Similarly, the square footage used K for 1,000, so I just convert that to 1,000. I wrap everything up, and I return the property, which looks like this. It's a mapping of the data we have available to the format that the API is expecting. So here's how I run this types of code. I load up my config file. I grab my credentials. I create a data access object based on those credentials. And the reason we're doing that and not just building it into the crawler is we are open to maybe having some different types of DAOs, data access objects, in the future. This one that we're providing right now stores to S3 with these S3 credentials for a caching layer and a few other niceties. There could be a reason we want to store that in Elasticsearch or in Postgres or somewhere else. So we can, as long as the DAO extends this or implements the interface we've shown in there, it'll work just fine, and crawler will interact with it. Crawler, we just need to pass in that data access object and these three pieces: the expiration rule that I showed you initially, the function that extracts the content, and the function that extracts the links we want to crawl. So let's go ahead and do both of those. Did I run DA already? I think so. Yes. And now what I'm going to do is I'm going to tell it the root page I want to start crawling. So I just need to crawl the top-level domain, because I see here that it's going to pick up all the states. When I go to the states, it's going to pick up their children and these details, so I should be just fine. There could be another site where this is, you know, you put in, instead of just one root page, you give it a queue of different items, but the crawler has a function, this is the only one you should need to call, called process queue. It takes a queue, which is a list of strings that are URLs you want to call. And in this case, I have verbose turned on, so I can see exactly what's taking place. And it'll return this work summary that we'll look at in a second. So let's run that. Okay, it's first processing my top-level domain, crawls it, parses it, saves the parse. Same thing for Massachusetts and Texas. So in the background now, this is respecting robots.txt. It's not crawling too frequently. It's trying to be a good citizen of the internet. And meanwhile, we could maybe walk away here, have a coffee break or something, I'll wait just a minute because I built a deliberately small site. Although I can run this here locally, we envision that eventually this will run on Lambda, which Samir will talk about in a moment. Then I get a nice summary here that it found and processed 9 total pages, and it took 27 seconds. Let's go ahead and look at what it returned, this work summary. Work summary is a list of these summary objects. They tell us what went on. So they say, for example, that it wasn't cleared from the cache, that it was crawled, there were 5 links found. That's on the root page. There were no parse errors, and in fact, it is parsed. So let's just, for kicks, let's go and remake that queue, which will now have been emptied out, and let's run this again and see what happens. All right, we skipped everything because it's already handled all these. It checked the cache and said, I don't have any work here to do, and it stopped. It stopped at just the root page because no need to go further. It knew it had everything else done. Eventually, we'll probably put some method that summarizes these so you can check that everything worked okay. We'll put more complicated logic around if there are parse errors, how we can send notifications. But basically, we want to provide this nice framework, which will probably evolve with time, but a framework where you as a contributor to OpenHouse can decide, do you want to focus on enhancing this crawler? Maybe you have opinions about how to do things that are multi-threaded and how to better enable port scanning or who knows what. You could contribute to the crawler and never worry about things. If you're someone that wants to be more hands-on with the data, all you need to do is get good at Beautiful Soup, define these 2 functions, and then pass them to the crawler, which will be worked on independently and provide you all these nice faculties. I'm going to skip this for the demo since I have it configured to run in production, but all you would do now that you've finished with the queue, the crawler holds all the work done in a queue, and when you run the upload method, it's going to send all those to the API, and you get similar work summaries about everything that's done. So that's the current state of the crawler. I'm sure we'll make improvements and iterate with it over time, but the goal of getting it where it is today is just to make it so a user has to provide those 3 things and pass them to the crawler. Just those rules and 2 functions, and you're good to go. So yeah, I'm going to hand it over to Samir, who's going to tell us a little bit about AWS Lambda and why that's a good use case for what we're building out with the crawler.
So what I'm going to do here is, for people who are new to AWS Lambda, I'm just going to give like a quick 10-minute introduction to Lambda. I'll also launch a custom Lambda function and invoke it with the trigger just to kind of show you how it works. So this is a Lambda page, and there's actually a really good few diagrams here I wanted to mention. The point of Lambda is to allow you to write code and upload it to Amazon, and then you can set up triggers to run that code. So even though the code actually does eventually run on a server, you don't have to manage that server. The idea is to be able to do very fine-grained, up to 100 millisecond type of granularity for the billing. So this is the fundamental architecture of Lambda. You upload your code to Amazon, and then you set up triggers. The triggers can be a variety of things. It can be a mobile app, like when someone touches something on an application. It can be an HTTP endpoint, or it can be something like some sort of trigger in an Amazon service, like a file being put into an S3 bucket, or some sort of new data being added to Amazon DynamoDB. Once these triggers are hit, then the Lambda function runs, and then it will terminate as soon as it's finished running. So here's actually a really good use case for Lambda. Like, imagine that a photograph gets taken and gets put in S3, and then as soon as it lands in S3, a Lambda will be triggered to resize that picture into 4 or 5 different sizes, one for a tablet, one for a smartphone, one for a desktop. And as soon as the resize of that specific picture is done, perhaps the resized pictures are put in S3, and that's it. That's the one specific trigger for Lambda. There's other use cases here too, like real-time stream processing. I'll let you skim through that image. And also ETL, where DynamoDB ends up being the trigger here. Actually, I do want to talk about pricing as well. This is actually a big deal. So Amazon gives you 1 million free requests every month and up to 400,000 gigabyte seconds of compute time per month. Really, the really good example I have is down here, which is the pricing example 1. So here, imagine that every time your Lambda function runs, you need 512 megabytes of memory. And imagine that you end up executing it 3 million times in 1 month, and it runs for 1 second each time. So that would end up costing about $18. It's quite a generous free tier as well. And the free pricing is basically a function of a few different things. One of them is memory, like how much memory do you actually need to run your code with all of its libraries. And the other function for the pricing is how many requests or how many like triggers are you going to invoke. And then the final cost is based on whenever a function does get invoked, how long will it run for? Will it run for 100 milliseconds, 1 second, or 10 seconds, for example? Okay, so that's kind of the pricing. And the final thing I wanted to show was the actual demo of Lambda. So when you log into Amazon Web Services, this is what you'll see. I'll just go to Lambda the traditional way. There it is. So this is a service that was launched at the end of 2014. You'll see that I have a couple of functions already here, but I'm going to actually create a new Lambda function so you can see how this works. I found it to be actually very, very quick and easy to do this. Notice that here there's a bunch of blueprints that Amazon has made available out of the box. It looks like there's about 51 of them. The one I'm actually looking for is a hello world Lambda function in Python, this one right here. But I'll kind of show you what other ones are around. There's a Slack one. There is also a SNS one. There's some S3 sample code as well that uses the Boto library. So let's look at the hello world Python Lambda function. Now, on this page, I can decide how I want to set up a trigger. In this example, I'm actually not going to set up a trigger, but I do want to show the different options here. The one that I found personally interesting was the S3 trigger. So in this trigger, I can decide which bucket I want to set up for this trigger, and then I can decide what exactly type of trigger I want to create as well. The one that might be useful for us is the put trigger. So anytime a file lands in S3, then it will automatically trigger this Lambda function. And at that point, perhaps the Lambda function will actually read the data in the file, perhaps it won't. But just the idea of a file landing in this bucket under, for example, the work directory would just simply trigger this. And then you can enable that trigger. Okay, so what I'm going to do here, though, is I'm going to remove this trigger because I'm just going to manually invoke it from the web UI here. So the next thing I'll need to do is name my function, and I'll call this my first function. And I'll give it a description. So I'll call this OpenHouse demo of Lambda. You can choose your code runtime. Right now, Java 8, Node.js, and Python are supported. I'll go with Python 2.7 here. So the next thing is, this is it. This is all of the Lambda function. It's importing JSON. It's printing loading function. This is the actual function, and you'll notice it takes in 2 different objects, an event and a context. Event is really the most important thing you should care about when you're getting started. Over here, you can see what we're actually doing is we're printing value 1 and also a specific item out of the event list, key 1, key 2, and key 3. And then we're also returning a specific event key, the key 1. Okay, so that's the function. The data that I pass in, like this event data, I have not defined that yet. But later on, when I'm done creating my Lambda function, I am going to create a list with 3 different items in it, and then I'm hoping that these specific items will run. By the way, you can pass in whatever you want into the event. It can be a list, a string, a dictionary. It can be whatever type of data structure I believe you want to pass in. Okay, so then this is called the handler function. What the handler function does is this is just the entry point into Lambda, so it's the first thing that will run when the trigger gets invoked. You can also choose roles, and I don't think we need that right now, so I won't do that. You can choose how much memory your Lambda function is going to need. You can also choose a timeout. I'll set a 2-second timeout here.
Nice.
And really, this is really all you need. Notice you can also upload a zip file or upload a file from S3 with the code to run your handler function. Okay, I'm going to hit next. It looks like there's an error here. Okay, I'll just choose my test role, I guess. That should be okay. Okay, so I'm going to do a quick review to make sure everything looks good, and then create the function. And in just a second, we should see on the dashboard that, here we go. Let me go back to functions, and now my first function shows up right here. So I'm going to go into that function. I can see the code that I have. I can see configuration metrics. Here's what the advanced settings look like. And I can see that I have not defined any triggers yet. And under monitoring, I can see how many times this code was actually invoked. It's basically everything is 0 right now. So next what I'm going to do is click on this blue test button, and I'm going to manually invoke this code by passing in this dictionary, actually. So in here, there's key 1. Just to make this a little bit more interesting, I'll call this Samir. I'll call that Kyle. And I'll call the value 3 Joy, so you can see that this is a real demo. So what I'm doing here is when I invoke my Lambda function, I'm passing in this dictionary with 3 different items. Now, for example, perhaps this could be like the root domain that you want to crawl, and you pass that in through this event function. And as soon as you pass in a root domain, then the Lambda function just starts crawling it, perhaps. Okay, so I'm going to hit save and test. And it should be literally running this now. It looks like it succeeded. I can see the execution result shows successful. It also returned the key 1, which is what I wanted my function to do, to return key 1. This specific duration was really small. It was less than a millisecond, about 1/3 of a millisecond. However, I was built for 100 milliseconds. The granularity here is 100 milliseconds, so we would want to try to second boundaries, perhaps. The memory I used really was only 29 megabytes. And also, I can see some log output here. This type of log output we can log into CloudWatch, for example. So if you remember, in my function itself, I had a bunch of print statements for printing value 1, 2, and 3, and that's what I'm seeing here. And there's a request ID as well, and a build duration, and all of this information is logged. Let's see. I'll go back to, what else do I want to show here? I can go to dashboard, and this shows kind of all of my Lambda functions and how long it ran. I have, for example, 3 Lambda functions, and it takes up really no code right now. All right, so that's the basics of Lambda. It's really easy to do. What I would really encourage everyone to do is check out some of these blueprints. That's what I found the most interesting. If you go to like S3 object, I'm going to just hit next on this. You can see that there's a bunch of like just boilerplate code that Amazon has given us that we can use to kind of build future functionality off of. Okay, and one last thing, we do at OpenHouse have a AWS Lambda function scraping package. I would encourage you to check out this document and comment on it, leave your thoughts. If you'd like to start editing this document and dive into this part of the project, please contact any one of these people on the Slack channel, and we'll give you full edit permissions. And I think that's really it. If you want to dive a little bit deeper into this, check out this document, which gets into some of the more advanced functionality, including the programming model. This documentation here, by the way, I found extremely good. So to go into this programming model, there we go. I'm just going to skip through a couple of these slides so you can see how this documentation is laid out. This context function, by the way, maybe I should mention this as well. This is how your code can be self-aware of the fact that it's running in AWS Lambda. So with this context object, you can do things like your code can be monitoring to make sure it doesn't get timed out. My timeout was 2 seconds. With this context object, while my code is running, I can be doing things like asking it, how much longer do I have before Lambda is going to self-terminate my function? So that was pretty cool. And it's just a way you can actually run this at the command line with some of the configuration options. Okay, I think that's really it. This documentation is good. I highly recommend everybody to check it out. You can just see some of the advanced settings that we can set. And that's really it. I'm just kind of getting started with Lambda. I think the next steps are to integrate Kyle's code with Lambda and try to run this on one of the sample domains.
Awesome. Thanks, Amir. That was a really great walkthrough. I'm really excited about Lambda in a couple of ways. I mean, there's projects outside of OpenHouse that I think it's useful for. But for us in particular, this fact that it's serverless, that I no longer, if I want to contribute, have to go, I don't know, set up an EC2 instance, mess around with cron to get things recurrent. I just have to build the parsing, set up a Lambda function, and get it scheduled, and all the DevOps kind of comes for free. And with that free tier you walked us through, it would cost virtually nothing for 1 or 2, maybe even a handful of domains. So it's a cool way somebody could get involved.
Yeah, definitely.
Awesome. And I think in one of our next videos, we'll go into how we integrate my code into Lambda. So look for that in the future. You may see it below this in the playlist if you're watching down the road. And I'll put all the links that we went over in the comment section right below as well.